Share screen. Okay, so if you're seeing my screen, you're seeing this question here.
Yep.
I feel like this is the type you're going to get on a partial fractions. You're going to get something where it's a over the first one t plus 4, b over the second one t minus 1, and it's 1 equals that. So the idea is you're trying to figure out, well, what is each one missing? Well, this one's missing a t minus 1. This one on the right's missing a t plus 4. And you focus exclusively on the numerator.
Okay.
So like on the way that this is set up is it's like at minus a plus bt plus 4t. There's really a plus here that I didn't write.
Okay.
So then the way this proceeds from here is and I think this is important to write for students is you write a 0t because you're matching the coefficients.
Okay.
0t equals at plus bt, and then you really you drop out the t's. So the sorry, this thing is not cooperating. So then so this becomes 0 equals a plus b, because you just exclude the t's. You just no, they don't even count, or whatever variable you're doing. But then you have to do the same thing with the constant. You set 1 equal to the non-constant term, so minus a. Wait, did I? This is 4b. That's a mistake there. 4b. So then it's minus a plus 4b, and then you have this system right here, system of equations to solve. And the instructors can make this as as easy or as hard as they want to be able to answer them. So the first equation gives you a equals minus b, for example, and so you got 1 equals minus a. I'm sorry, well, we would substitute that in, so you would get minus a minus b plus 4b. So it ends up getting 5b. So 1 equals 5b, b equals 1/5. And then a, you get a from back there. You get a is minus 1/5.
Okay.
But we're not done. Like that's like the partial fractions is it's not even the calculus. The calculus is after you do the partial fraction. So you put your a over t plus 4. So your a is minus 1/5 over t plus 4.
Okay.
Your b is positive 1/5 over t minus 1. And this is what you're integrating now. And when they're linear like this, you just get the natural log. That's natural log absolute value t plus 4, negative 1/5 out in front. Natural log of t minus 1, 1/5 out in front, plus c.
Okay.
So the question is like, will your instructor expect you to work out a full partial fractions decomposition? Sometimes they just want you to set it up. I mean, the way you've presented it to me here, I mean, I would say it's one question of each one.
Yeah.
One separable differential equation, one partial fractions that you solve all the way through. If you're going to do 2 partial fractions, you're probably going to be asked to like set up but not solve.
Yeah.
Which,
Yeah. Probably. Yeah.
Yeah. All right. So we'll see. So number 3, look at number 3 next. That's okay.
Yeah.
So the bottom generally has to be in factored form. It's currently not in factored form.
Okay.
So you got to be good at factoring. And it's the same deal. You set the 1 equal to a over x minus 1, b over x plus 1, and then you figure out what each one is missing. Well, that's missing an x plus 1, that's missing an x minus 1. So 1 equals ax plus a plus bx minus b. And again, there's no x here, so sometimes it's good to write 0x to like get that like firm, like, okay, it's there.
Mhm.
So this time it's 0 equals, and you need the ones with x, a plus b. And then the other one is 1 equals a minus b. So this time the system's a little bit easier to solve. You actually can just add them up. So don't forget about like the easy way to solve systems.
Mhm.
A is 1/2, and then use that back here, or the other one, but the first one's a little bit easier. A is equal to minus b, or actually I should write that the other way. B equals minus a, which is minus 1/2.
Okay.
So once you get the coefficients, you go back to this line right here, and you rewrite your integral. It's a over x minus 1. So it's 1/2 over x minus 1 plus b. B is minus 1/2 x plus 1. And you're integrating from 2 to 3 dx. So just like the last one, it's natural log.
Okay.
Natural log absolute value x minus 1, 1/2 out in front, minus 1/2 natural log absolute value x plus 1, evaluated from 2 to 3. So this one has the added complexity of like being able to, you have to put the endpoints in. So 1/2 natural log of 3, or 2, sorry, 2, because 3 minus 1 is 2, minus 1/2 natural log 4, minus, now we put the bottom one in, it's 1/2 natural log of 1, 2 minus 1 is 1, minus 1/2 natural log of 3.
Okay.
And this one's kind of a special problem because you can actually simplify a lot of this. This right here is 0. Natural log of 1 is 0. Okay, so this becomes 1/2 natural log of 2. Now the next one here, 4 is really 2 squared. So you can bring that 2 actually out in front, which makes this 2 times 1/2, so just natural log of 2. This one goes away. Minus a minus gives you a plus, so plus 1/2 natural log of 3. And then you have a half of 1 minus 1, so it's minus 1/2 natural log of 2.
Okay.
And so you can really keep going here. Like you rewrite it as 1/2 natural log of 3 minus 1/2 natural log of 2. 1/2 becomes a power, so this is natural log of the square root of 3 minus natural log of the square root of 2. And then you can combine them to root 3 over root 2. This is pretty extreme, but this is like what the superstar math student would do.
Okay.
Maybe actually they'd probably write it like this: natural log square root of 3/2. I don't know. They might even rationalize. There's so many things you could do. I mean, I don't know when you're done.
Yeah.
Okay. We should do at least one more, probably like number 4.
Okay.
4 is kind of the edge where I feel like you're getting a bit too extreme for what you're going to be asked to do.
Yeah.
Although I don't know. This one is x minus 1 over, and then you got to factor the bottom. So x plus 2, x plus 1. And then this time you're getting a over x plus 2, b over x plus 1. There are other variations on this, which we're not getting into yet. We could. That would be something to maybe think about.
Okay. Studying later.
And I'll show you the sort of the cheat sheet on that. So again, like x minus 1, x plus 2. This time though, you've got x already. 1x minus 1 equals ax minus a plus bx plus 2b.
Would it be x plus 1 or x minus 1?
Yes,
Okay.
that would definitely change the answer. So you set x, you set 1 equal to the x1, so a plus b, minus 1 equal to the a plus 2b's. And so to solve this one, I would have you subtract. I would have you subtract top minus bottom.
Okay.
You are you allowed to use a calculator on these?
I don't think so. I think
Okay.
he's
All right. That always changes the game here. A minus a is 0, so it's b minus 2b, so it's minus b, so b is minus 2. And then a is 3. You get that from the first, putting that into the first equation.
Okay.
So again, like this is not the calculus. Like I think one of the things that I'm pretty sure why on calculus tests, like they generally don't emphasize this because there's no calculus. Once you break it apart,
Yeah.
that's the calculus, and it's pretty easy calculus.
Yeah.
So your a is 3 over x plus 2 plus your b over x plus 1, and you're integrating from 0 to 1 dx. So it's 3 natural log abs value of x plus 2 minus 2 natural log abs value of x plus 1, evaluated from 0 to 1. We don't need to go through that again, but that's the
yeah. Okay.
Okay, so let me go to Lamar math. What is this? Partial fractions. And there is kind of a guide to this. All of the problems we have been doing have been this first type.
Yeah.
So let me see if I can. They use a slightly different notation. So your textbook will have something even different than this in terms of a notation. But for every factor in the denominator, notice all of our factors have been in this form, ax plus b. But they've been to the power of 1, which is really important. Like if you go back and look at this one, power of 1,
Mm-hmm.
you know, and so on, power of 1, not this form, in the factored form. That's what you gotta look for in the factored form. So what this template chart thing is showing you is showing you that it's showing you that you put your letter over your a over each one, and like the one we're using is this, you know, big B over the next one, you know, C x plus D, like that's the one we've been doing.
Yeah.
This thing, you're not going to see this, but the one you might see, and this is where it's like, well, do we really want to spend time doing this type? Is when the numerator is now an ax plus b. Like you have to find both a and b, big A and big B, because the thing on the bottom is not factorable.
Okay.
And that like increases the difficulty a lot.
Yeah.
So what am I seeing here? Am I even seeing any of these? No, I'm not. That's interesting. I'm not seeing any like that. I am seeing, I guess we should talk about a few more of these.
Okay.
Let me, do you have answers to all of these or just certain ones or none?
Let me see. Give me a sec. I exited off. I'm gonna go look in my history. Yeah, I have the answers. So
Okay. So like this one, see how the bottom are all linear? They're all to the power of 1.
Yeah.
So don't worry about the top. The top's not important. So this is a over y plus b over y plus 2 plus c over y minus 3. And like in this case, you would multiply a by y plus 2 and y minus 3. B you would multiply by y times y minus 3, and c times y plus 2. Can you see why that is the case here? It's basically whatever's missing from it.
Yeah.
Okay. And so this one you end up getting you get 3 equations and 3 unknowns.
Okay.
Hence the question, or not hence, I asked you a question, I was like, can you use your calculator? Because at some point you can't do these by hand.
Yeah.
But you can set it up.
Okay.
So like your instructor might say, set up the system. And that would be the case here.
Okay.
Because you probably wouldn't have all that time to solve it. Are you doing these like in an hour, half an hour? What are your time constraints on?
Like an hour. I mean, he's not making them extremely long. So
Okay.
one I've took me like 25 minutes. The other took me 40 minutes. So they're pretty.
Got it. Yeah. Okay. So 6, let me talk about 6 here. So you always try factoring the bottom, not the top. Top, you don't really care. The bottom is x times x squared minus 1, which becomes x times x minus 1 times x plus 1. So it is essentially the same as the previous one.
Okay.
You would have a over x, b over x minus 1, and c over x plus 1.
Gotcha.
All right, let's move to question. So I guess 7. So 7 is that first one where we have to draw on the reference, and like this is where I would draw the line. So this is, you're probably not going to get this, but I will show you how to do it in case you do get it. All right, so look at this chart here on the right again. Do you see that the x minus 1 is like this type?
Yeah.
So you would do a over x minus 1.
Okay.
The x plus 5 squared is this one down here, because and your k is 2 in this case.
Okay.
So here you do b over x plus 5 plus c over x plus 5 squared.
Okay. Combine.
So I have seen in like college exams where they put like 7 here and they want to see that you know how to write it out.
Okay.
What will your instructor do? I don't know.
Yeah.
But without this reference, like I don't know how you do this. Like I don't remember this stuff. I mean,
Yeah.
this is not important, but it's, okay. So now let's look at 8. 8 is unfortunately even just a more difficult variation. It's really getting up there in difficulty. I'm sorry, 9. So we're gonna do 9. 8 is like 7, so we'll do 9. And after this, maybe we'll transition to the other one. So this one, okay, the what's different about this one is it's an s squared or an x squared. What this one is, let me grab it. I got to grab the whole chart this time. So the s squared is actually this one down here, but it doesn't have a bx or bs and a c. It's just that. and that's why it's maybe hard to like recognize, but it's one of these. So you would go ax plus, I'm sorry, well, it's, I guess it's s, as plus b over s squared for that one.
Okay.
And then your s minus 1 squared is like this one. So that means you would do c over s minus 1 plus d over s minus 1 squared.
Okay.
And I mentioned this earlier, like every letter tells you the size of the system. So this is 4 equations and 4 unknowns. There's no way you're doing that by hand.
Yeah. Yeah. Okay.
All right, so that they just get more difficult. I would say this is probably sufficient, but you're the customer. If you want us to keep doing more, we can. We can move on to the other ones.
No, yeah, that one's fine. We can
All
move
right.
on.
Okay. I'm going to do a slightly different separable differential equation to start. Just to kind of bring them. So it's separable means that you can separate the variables. This is kind of your classic question here where you need to move the dx over here and you need to move the y over here. And you're essentially multiplying both sides by dx and then both sides by y. So you get integral y dy equals integral x dx.
Okay.
And so you just integrate both sides. You're going to always integrate both sides.
Okay.
So this is 1/2 y squared equals 1/2 x squared plus c. My preference is to put c on the right-hand side.
Okay.
Sometimes you can solve for y. This one's not really clean. This is your final answer. I mean, this is totally correct. Now, when we were talking the other day, like these are initial value problems, which none of the practice ones that you've provided are, and that's how you find your C.
Okay.
Do you remember? I hope you remember us talking about that. Yeah. None of these are initial value problems, so that's what we got. Let's do number 4 next. It kind of fits the fit what we're doing here.
Okay.
I'm sorry, this is really not interesting.
No, it's fine.
There are parts of calculus that are super important and applicable to real life, applicable to even things you've already done and will do, but not this. Not this at all.
That's okay.
Yeah.
I didn't expect it to be.
All right, so you gotta separate the variables. And you generally multiply and divide. I mean, there's a few instances where you wouldn't. So if you multiply both sides by e to the 2y, and you multiply both sides by dx, you get integral e to the 2y dy equals integral 2x dx. All right, so the right side's probably the easier one to integrate antiderivative x squared. On the left, I was showing this to another student. I think this is a worthwhile one to remember. E to the u du, the antiderivative is e to the u over u prime.
Okay.
Otherwise, you got to do a u substitution for it, but it's e to the 2y over 2.
Okay.
This one you can solve for y, which is why I think your instructor might give you something like this, because there's some prerequisite stuff that you would need to know. You need to know to clear the 2. E to the 2y equals 2x squared plus 2c, but instead of that, you would just write c. You wouldn't want to keep doing that. If you did get an initial value, you'd want to solve it back up here. Take the natural log of both sides. So you get 2y equals natural log 2x squared plus c, and then divide by 2. So y equals 1/2 natural log of 2x squared plus c.
Okay. Gotcha.
Right, so three is one you could do on your own. Now it's no different than what we've done. But we'll start looking at some of the other ones here. So number one, I think number one is more difficult because you got to remember your exponent rules. You got to remember that this is really e to the x times e to the minus y, or even better, e to the x over e to the y. I can review either of those properties if it's not clear.
Yeah, I get that, yeah.
Okay, so then your dy dx equals e to the x over e to the y. Well, you do the same thing. You get the y's on the left, and you get your x's on the right.
Okay.
So your antiderivatives are the same for both. And then you undo e with ln. So you get y equals natural log of e to the x plus c.
Got it.
All right, let's look at 5.
Okay.
5 could be unclear because you might think, oh, well, Matthew said I can't add or subtract, because you think, oh, I'll subtract the 2y. You can always divide by the whole thing. You can divide both sides by 2y minus 1. So
Okay.
you get integral dy over 2y minus 1 equals integral dx. And it's okay to just have a dx. It's okay to just have a dy on the left.
Mhm. Gotcha.
So on the left side here, it's kind of another one of those. They sometimes show you this, and it's 1 over, whenever you get this like 1 over ax plus b, you get your antiderivative is natural log ax plus b over a.
Okay.
But really it's a 1 over u situation where it's natural log of u over u prime. So it's natural log 2y minus 1 1/2 equals x plus c.
Okay.
Do you want us to solve this for y, or is it okay? Okay. So you multiply both sides by 2.
Okay.
So you get 2x plus c. You undo ln with e on both sides. So you get 2y minus 1 equals e to the 2x plus c. But the way this is generally written is it's e to the 2x times e to the c, and then this part becomes c. So it's really c e to the 2x. You'll see that quite commonly on these types of tests.
Gotcha.
Add 1, divide by 2, so y equals c e to the 2x plus, and then you're dividing this by 2, this by 2. You could wrap c over 2 into another c, which is why it's so important to actually solve for the value of c up here, if you can.
Yeah. Okay. Gotcha.
All right, so the next one here, I guess we can look at is number 6.
Okay.
All right, so number 6 is really, if you don't know how to kind of navigate the starting steps here, you just would never get it.
Yeah.
I see that there's a y in both terms, so you can factor that out. And then I think it's pretty clear, okay, I got to move the y to the other side.
Okay.
Right. And I after this problem, I think I remember you sent me some problems the other day that were maybe a little bit more challenging. They really were
Okay.
like, what do you do
Yeah.
to get things going? So this dy over y, 2x plus x squared dx. So again, natural log absolute value of y equals x squared plus 1/3 x cubed plus c. Oh, another thing I didn't mention the previous problem. When you undo ln with e, you don't need the absolute values anymore. I kind of
Oh, okay.
anticipated that here.
Okay.
It's because it applies in a lot of these, like, we don't need to talk about why. We just need to talk about that's what you got to do. So y equals e to the x squared plus 1/3 x cubed, but that e to the c can come out in front like that.
Okay. Perfect.
All right. You sent me something a couple days ago. Yeah, so like these were all separable differential equations
Okay.
that I'm going to just snip them all in for the moment. Do you remember sending me
Yeah.
this
Yeah.
grouping? These are all separable differential equations. Like
Oh.
the first one I think is really tough because you got to do a weird thing, but these are all that type.
Okay.
So should we go through some of these? Do you want
Yeah.
me to find
So,
new problems? What do you want us to do?
yeah. Whatever ones you think would be the most beneficial.
Sure. Yeah, number one, we'll start with that.
Yeah.
Dy dx, y prime, they're the same.
Yeah.
1 plus x squared plus y plus x squared plus y times y. So what I see right away is there's a y in both of these on the right here. So it gets me to 1 plus x squared. And then I'm like really excited because I got the same thing in both. So now you can factor it out. You're factor by grouping here, basically.
Okay.
Because you don't add and subtract things, and not in this course at least.
Yeah.
Yeah, 1 plus x squared times 1 plus y. And you have that, aha, okay, now I can divide both sides by 1 plus y.
Yeah.
So you have integral dy over 1 plus y equals integral 1 plus x squared dx.
Gotcha.
And so natural log absolute value 1 plus y equals x plus 1/3 x cubed plus c. E both sides, you get 1 plus y equals ce x plus 1/3 x cubed. Y equals ce x plus 1/3 x cubed minus 1.
Okay.
I don't think we did this one the other night. It's number 5 here.
Okay.
Just written differently. It's the same. But we're so used to, like, we've been moving y left, y left, y left. Like you don't, y is already on the left. You don't have to,
Yeah.
you just have to move the dx over. So it's integral 3y squared dy equals integral 1 dx, or just integral dx.
Okay.
So then on the left, it's y cubed. On the right, it's x plus c. You can always solve for odd powers. It's the even ones that are problematic.
Mhm.
The even ones, look like this on your, some variation of this,
Yeah.
whereas the odd ones have a nice behavior like that
Okay.
generally. So y is the cube root of x plus c.
Okay.
think we'll look at 7 next.
Okay.
Yeah, so here, I mean, this is horrible. This is like, well, what do I do? Well, y is under a root. Why, but it's really actually no different than this one. You just divide it out.
Yeah.
Which maybe we don't teach that. I don't know. These are all kind of non-obvious if you haven't done them before. You're not sure what to do, but on the left is a small rewrite. I'd probably write it as 1 minus y to the minus 1/2 power, just to make it easier with the power rule.
Okay.
So it becomes 1 minus y to the positive 1/2 power over 1/2. But you have to think about what's going on in here. You have another one of those situations where the derivative of the inside has to be accounted for, so that negative has to come there.
Okay.
And it's a u substitution, but you really don't want to use like this. It just gets a lot of work.
Okay. Gotcha.
So then equals x minus 1/2 square root 1. I'm sorry, 2. Got to flip it. 1 minus y equals x plus c. So then you would divide by that. You'd square both sides. So you'd get 1 minus y equals minus 1/2 x plus c squared. And then you move the y, subtract this over. So y equals 1 minus 1/2 x plus c squared.
Okay.
A lot of algebra in a few steps, but I'd be surprised if you got anything like this.
Yeah.
All right, let's look at 9, I guess. We haven't done 9.
Okay.
I don't remember us doing that the other night. Okay, so this problem here is kind of interesting from the perspective that it's really scrambled. I call these scrambled,
Okay.
which is like think about this. Like when a long time ago, you learned how to solve this problem, right? You subtract 4 from both sides, no big deal. But this is the same problem. And so is this. And so is even this.
Yeah.
And they're all scrambleds of this.
Yeah.
And that's what this one is. It's like just another obscure way to like present the same exact thing as something else we've actually already looked at. So you divide by e to the x. So you get y prime plus 1 equals e to the minus x, because it's preferred to write it that way. And you could say I'm contradicting myself. I absolutely am. Now you subtract 1 from both sides, which math's about exceptions. If you want to get an 80% in math, you just learn all the rules and never apply the exceptions.
Yeah.
Maybe in real life too. Maybe that's something else going on there. But yeah, you do subtractor. And I said, well, you generally don't do that, but obviously you must do that here. Yeah. Why is that okay? You don't, because the dy dx is held here. That's why you don't leave the 1 on the left, because you have to break it out of this. Yeah. So it would be wrong to be like dy dx plus 1 equals e to the minus x. Yeah. Although this is what's called believe it or not, this is called a linear first order differential equation that you can solve, but that's in another class. So dy, integral dy equals integral e to the minus x minus 1 dx. Y equals minus e to the minus x plus C.
Okay. Not too bad.
All right. We covered partial fractions. So let's just go back and look at that one more time here, just to see if there's any sort of questions. It's really all about this right here.
Okay.
And your book has something similar. I don't really like this one because I don't like the matching A's, big A's and little A's, but it's a good chart overall. Please look at something like this. That's all. If you can get this down, you will know how to do all the partial fractions problems.
I just took a picture of it, so.
Okay. And then the ones that I really emphasized were generally like you split them apart. Let me find one here. There it is. You split them apart and then you do this systems. You should be prepared to do a system tomorrow.
Okay. Okay.
2 by 2. And if you have to integrate, they're almost always LNs. Almost,
Gotcha.
80%. So
Yeah.
okay.
Okay.
If you're okay, I'd appreciate stopping a little early. I mean, we covered a lot of ground here.
Yeah, I'm good with that.
All right.
Yeah.
Well, thank you so much. I'll send you the notes here shortly, and I'll see you next time.
I'll see you Thursday.
Have a great night. Bye now.